Hello everyone. In this session, we are going to discuss about IAM. Before starting that, let's see what we did in a previous video. We discussed about load balancer, then type of load balancer, benefits, and also do the show you in the console how we can do that. After that, we discuss about DNS routing, including policies, different DNS policies, and how our DNS and load balancer work together. So now we are going to discuss about identity and access management. That is IAM. IAM is a web service that help you securely control access to your AWS resources. How we can control the access on our different AWS resources. Till yet, we keep working only on the root user account. Root user has a full power to do anything into the account, but we want to restrict the control. Like this person is only responsible, one person is only responsible for EC2. One person can only work with the S3. Not every person is there. Not every person there can do anything. No, we don't want like that. One person control S3. In S3 also what we can do, read only permission or listing permission. And one person who can create, who can delete the bucket there. Similarly for S3 also, who can do what? This person only have the control over EC2. In EC2 also we can again restrict more finer granulation filtering. This person is only for the read-only conditions, means can only see the list of EC2, and some person is responsible for logging. So in this way, we can control access to AWS resources. So what I want to tell, like if we say uh, we have this particular resource here. We have some resources here. So we type like www. It's I'm getting confused. Thing is here w, then w, then w. Whenever we start about the IAM discussion, always consider these things. This w who, second w what, third w which, who user. First you need to prove your identity, or we need to create an identity. Second, what he can do, what he can do there. Either read only permission, write permission, or as an administrator for that particular like EC2. That is a permission. And which naturally on which resource. Who can do what on which resources. So these all we set with the help of IAM. With IAM, you can manage permissions that control which AWS resource user can access. Not like root user can access everything, can go to the S3, can go to the EC2, because root user is the master. It is recommended in the industry also, so never to use a root user account. Create one administrator having the full access and put the root user account in somewhere in a safe place. If root user account go to some wrong hand in the company, can just finish everything, can destroy everything, can completely demolish everything there. So create these users and then use that. You use IAM to control who is authenticated, sign in, who is authorized as permission to a specific resource on what? Same thing. Who, user, authorized, what, resource, which. So I am provide the infrastructure necessary to control authentication and authorization of your AWS account. Hope something is in mind. What is IAM? With the IAM, we do the fine granular, we implement fine granular policy to the user who can do what. So in other languages can say IAM is a framework used to define who can access what, how within a cloud environment. It's a key for security with least privilege and access control there. Clear about the IAM? Basic introduction what we can do with the IAM. Good. The key feature, we can do that with the help of multi-factor authentication. Everybody is familiar who is doing the internet banking, you know about the multi-factor. If you want to transfer some money somewhere, then one of the password come to your phone before that transfer happens. Then password policies using the hard password policy, PCI card and data security standards compliances. Like every ATM have some rule and regulation, that is the PCI cards. Identity information for assurance, shared access to your account. Shared access to your account. There can be a multiple IAM user who have the access on different resources there. In within your account, you can do that also. Granular permissions. This person have only the permission for the read only to S3. Cannot create, cannot delete there. Similarly, have the only log permissions to verify the logs in the EC2. In this way, you can implement granular permission to the different user depending on the level. Secure access naturally when you are creating different IAM user with different policies is totally secure access. And identity federation, that is a federated service, that is also the part of identity and access management. So these are the key feature of IAM. First thing, who is user? Who is the user? User is an entity that you create in AWS account. The IAM user represent the human user or workload who use the IAM user to interact with the resources. Mainly a human, mainly the a person who is going to handle that particular AWS resource to whom we are giving the permission. So first is name and then its password and other credentials. IAM user with administrative permission is not the same thing as the AWS account root user. What we do normally, as I have told to you, never to use the root account on the daily basis. So what we can do, we create one root user will create one administrator. So don't think either administrator has a full access on the account, but still it is created by the root user. So root user has a superpower. Administrator has the power, but the root user has a superpower. Root user still have the control on administrator. User can again delete the administrator, but administrator backend role cannot disable the root user. Correct? IAM user can be an admin to manage different resources, can be the end user, or can be the system for particular AWS resources there. Let's see one thing, do one thing. Come to the console. Come to the console. Go to here and come to security and identity compliances. Click on security and identity compliances. Here you will find the option of IAM. Right now we are logging with our root user. From here you can create your different users and group that we are going to discuss. Like user here, just delete the old one. I'm going to delete old one to make you more clear everything. So from here we can create a new user. Create user process is very simple. Give any name, like a game the internet test one. Password, I want to give a password, custom password, or you can use the auto generated password. So password should be complex. And okay, I just going to remove this policy and next. Want to add any user? No. Either we can add to a group here, we can copy the permission to give the policy to implement some policy on the user. We can copy from another account also, or can attach the direct policy from here. But right now I'm not going to implement any policy here. Just create user without any policy. So now user has been created. Now what I have to do? Copy this. This is a console, login console. Never think IAM is a different account. No, it's the part of root account. It's a comes under a root account. So in this entire console, in the URL, you can see first part is the who is the root user. Root user account ID. Already copy it. You just go to the cognito mode, paste it here. So you can see here. Can take some time, no issue. Yeah. Account ID of the user. So account we have created test one. What is the password we set there? We have to enter that password. Sign in. How? What? Let me check what user we have created there. Oh, TACT by the spell mistake. That mistake I have done. Continue. Yeah, TSCT. Sorry. TSCT1 by spell mistake I have done that. Home and sign in. So now we sign in as a IAM user here. Okay. So cognito mode. So now this user does not. Okay. In the meantime, it log in. Let's come here. Let happen. So how we can log in? What can the security credential? Normally keep here that I recently. Sorry. One is the keep here. If you remember, when we create an EC2, there we download one keep here. Whoever watched the previous videos of EC2, we download one key pair. We have a private and public key. Second is the access key that we have to use. Like here, I will show that also. When you go to the come here, yeah, go to the user. When we go to the account, we go to the security credentials. We can do create access key to access like CLI or Linux. So we have to use this access key. Right now we are for the window. We can use it. This one keep here. For CLI or Linux, you use access key. Email ID and password to log in. That can be the IAM user. There can be the multi-factor authentication. AWS provide numerous ways So there are a number of ways how a user can log in there into the AWS account and then can use that, access that resources. So if you come here, this user has been logged in. TSET user is login. You can see here, it's a part of root user. But now by default, when we create the user, does not have any permission to do. If you go to compute section, go to the EC2 section, you can see here, does not have any permission to do anything. By default, the user create does not have any permission. Now we have to assign in the fine kernel configuration. I'll go to instant dashboard. Access denied, access denied, access denied. But when we give the permission, when we assign very fast, because it will take so much time now, go to user, go to add permission. Like I'm going to give in the only EC2 full permissions. Attach the policy directly. Search here for the EC2. Suppose for example, I want to give him EC2 permissions. Check here you can see here so many options here. Registry pull on, read only permissions, auto scaling permissions. So very fine you can do. Right now I'm going to give the full permissions. Next, and add permissions. As soon as we add the permissions here, now if we go there and refresh this page, yes, now you can see here, user has the full permission to check everything either for the listing. This is second thing. It's my free tier account, so I overuse that. That's why. But here you can see everything has been changed now. So in this way, we can assign very fine grained permission to the user with the help of IAM. Correct? Feature has user long-term credentials, username, password, or access key, whatever we are using. Can assign permission via policies used for individual identities. Like we create one set, one user, then assign some permissions via giving him via policies. So each individual identity have its own role. And same we can use access key to log in into the CLI again. Now we use the console password there. All clear? Next is a group. Nothing, individual user, rather than keep assigning the permission to the individual user, what we do? We can create a group. Whenever we create a policy on the entire group, whoever user is, we add in this group, automatically get the permissions. No need to manage the individual user independently. We can create a group, assign the policy on the group, whoever becomes a member of that group automatically get that permission. Define a group as a collection of users that inherit the same set of permissions. Like this for the dev, this for the admin, sorry, this for the admin group, this is the HR group, this is a marketing group. So we just assign the policy on a group, and all the user that exist that is connected to that particular group get the full permission to do that. So this way I have told you a specific group we can assign specific, like this use group have a specific permission on one S3 bucket, or like EC2, which EC2 this person can log in and what he can do there. We assign the permission. AWS define group as a collection of users that inherit the same set of permissions. Already discussed that. Next is a role. IAM role, little difficult to understand and tricky. So what I say, IAM role is an identity that you can operate in your account that has a specific permission. That has specific permission. An IAM role is similar to IAM user. Keep it in mind. It's totally similar to IAM user. In that, it is an identity with permission policies that determine what identity and what can do in AWS. What can and what not, cannot do in AWS. However, instead of being uniquely associated with one person, only this is the difference. Role is not associated with any one person. A role is intended to assumable by anyone who need it. Can take it by anyone. Also, the role does not have a standard long-term credentials such as password and access key associated with it. Instead, when you assume a role, it provides a temporary security credentials. Keep it in mind. It is not a permanent role. It will not provide a permanent access like your password and access key. Anytime you log in with the password, anytime you log in with the access key and start using. But it is a temporary security credentials for a particular role session. AWS identity with permission policy what determine access available to the identities assumed by anyone who require them similar to very similar to the user but not exactly similar to the user. No password protected, not any access key there. That is the difference. User have a particular password or access key, but role does not have any password and access key. It's a temporary credentials. Like rather than making more confused, a specific person or specific application, like any application server, require to access one particular S3 or some database server for a time being. So with the help of role, it get a temporary credential to go that database server, to go that database server for temporary access, not a permanent access. Because it's not possible for application to application communication to give any ID and password. So we create a role there to give the permission from one application to one account, one resource to another resource access. Okay. So in this way, role works. The long theory I have already discussed. You can use a role to delegate access to the users, either can be to the application or can to the service that do not normally have access to other resources. For example, you might want to grant user access to resource they do not usually have, or grant user with one account to resource in another account. In that time, we can create a role, or might want to allow mobile app to use AWS resources, but don't want to embed AWS keys with this app. So all the temporary credentials it can provide. There are so many examples I have mentioned here. Or you might want to grant access to your account to third parties so that they can perform and edit to your resources. So this is about the role. Feature, no credential by default, enable temporary and secure access, ideal for cross account access and service to service communication. For example, EC2 instance assume a role to read files from the S3 bucket. Hope now clear about the role. So policies, I have discussed everything. Policy is an entity in the AWS that when attached to an identity or resource, define their permissions. AWS where these permission policies when a principal such as a user make a request. Always keep it in mind. If there is one deny permissions and one is allowed permission, deny always in the win-win condition. Deny condition always win. This is the flow chart how it works. If anything is denied, it will check. If there is yes permission, denied, yes, then deny. If no, then it will check for any allow permission. If there is allow permission, then allowed only. If no, it again get denied. Means deny always in win-win condition. Deny condition always win. Whenever implement some policies, always look, there must be one allow. Otherwise, everything is denied. As I have shown you, the user we create does not have any permission, all deny. We explicitly allow him for some policy. Like we allow the user for EC2 permission only. If you want to access S3, no, denied. Everything is denied by default. This is JSON format for permissions. Next, the time in transit and encryption in transit and rest. Transit means on the way. Some data is going on the way, or it is in rest, means in your hard disk, in your storage part. So that how you want that data. When it's going on the way, it should be encrypted, and when it is the rest, it should be encrypted or not. Encryption at rest protects data on disk, either in database or object storage like S3 or any file system, from unauthorized access when it is in the disk. How it works? Data is encrypted before writing to the disk. There are many algorithms. Most common is the AES 256. Encryption key are managed by the cloud provider, like key management system by the AWS or other customers. That totally depend on customers. The benefit is same thing, from to protect your data from any unauthorized access. So clear? If you want to talk opposite to that, encryption in transit secure data as it moves between the client and server or between the services across the network. So how it works? Encrypted using TLS, transport layer security, or SSL. Ensure confidentiality and integrity during the communication. Same benefit, prevent eavesdropping, man in middle tag, or any type of data tampering. Essential for the secure API communication and remote access. Means how you want the data when it is on the wire, when it's moving from one application to another application, and rest when this data is within your hard disk. Okay, so this is about data transit and data at rest. So what we discuss? We discuss about IAM, user, role, and groups. Then we discuss about data in transit and data at rest. So thank you very much. See you in the next video with next topic. Till then, goodbye.